In this podcast, we're going to be solving some trig word problems. Sometimes we'll have a diagram, and sometimes we won't. When we don't have a diagram, we'll have to draw one. Here we have a diagram, so let's take a look at our word problem. While standing at Yavapai Point near the Grand Canyon, you measure an angle of 90 degrees between Powell Point and Woodforest Point. And you can see those on our picture right there, our diagram. You can see that 90-degree angle, and that could be measured using surveying equipment. You then walk to Powell Point and measure an angle of 76 degrees between Yavapai Point and Woodforest Point. The distance between Yavapai Point and Powell Point is 2 miles. How wide is the Grand Canyon between Yavapai Point and Woodforest Point? So we can measure land, on the ground. You can take one of those little rolly things and measure the land on the ground. You can measure angles, but you can't really measure across a canyon directly. However, indirectly, using trig ratios, we could. So when we're solving problems using trig ratios, we want to identify how the sides relate to the given angle to help us decide which trig ratio to use. Right? So we're given that 76-degree angle there. Across from that angle is our opposite side. Next to that angle is our adjacent side. Opposite and adjacent, why, that must be tangent. So now if we take tangent 76-degree angle is equal to the opposite is x, the adjacent is 2, and now we'll isolate x by multiplying both sides by 2. So we have 2 times tangent 76 equals x divided by 2 times 2. Right? So now our x is isolated. And now we can use a calculator. We can multiply 2 times tangent 76 to get our value. All right, let's see. I have a calculator handy. Of course, I have the lights turned off so I can see the whiteboard really well. So it is a tad dark in here, but I think I can see well enough by the glow of the projector. So 8.022 miles. Right? I rounded to 3 decimal places there, and I rounded up because the digit after that was a 5. So there we go. There we found it. This is no different, really, than when we're solving, when I give you just a triangle to solve for a missing side. Right? The only thing is when we don't have a diagram, we're going to have to draw one. Right? And that means we're going to have to know a few vocabulary words. All right, so this is in your notes. Here we have our steps for solving trigonometry word problems. All right, so hints and clues. Draw a picture. If one is not given to you, draw a picture. All right, so look for keywords like nearest degree. You must be finding an angle. Nearest foot or meter, you're looking for a side. Make sure your calculator is in degree mode. And remember our trig ratios. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And our steps. If you didn't get it from the hint and clues, draw a picture is our first step. Number 2, decide, are you looking for a side or an angle? If it's an angle, we're using the inverse. We're using arcsine and arccos or arctangent. Determine your angle of interest. It is either, number 1, the angle you're looking for, or number 2, the angle you're given. Label your triangle. Okay, whether the picture is given to you or not, when you draw your picture, label the picture. If you have a picture, label the picture. Right? Label which is opposite. And you want to make sure you label opposite. You can add this to your notes. Adjacent and hypotenuse. Right? Relative to the angle. Relative to that angle you're given. And actually, I don't know why I don't need a parentheses there. Relative to the, I'm going to put given angle. And I'll put the parentheses there. Determine which trig ratio you're going to use based on what you're looking for. Right? That's why we labeled the triangle. You'll solve for x or the angle. Round is directed, and don't forget to your units. Don't forget. So don't forget your units. All right. Either it's degrees or it's some linear measurement. So I said you were going to have to learn some vocabulary words. All right? So angle of elevation and angle of depression. Because in word problems, right, with no picture, angles will be described based on whether they are an angle of elevation or an angle of depression. And you will need to put the angle in the right location. If you put the angle in the wrong location, your answer will not be correct. All right, so angle of elevation is the angle at which your line of sight changes as you raise your eyes to see something above you. All right, so if I'm on the ground over here where it says theta, and I look up, that's my angle of elevation. If I am sitting at the top of the tree and I look down, that's my angle of depression. So angle of depression is the angle in which your line of sight changes as you lower your eyes to see something beneath you. It's the angle below the horizontal that an observer must look to see an object that is lower than the observer. Right? So angle of depression is how I have to change my eyesight, my line of eyesight. I can't be looking across, right? I have to look down. And when I look down, that angle, that is my angle of depression. Okay? By the way, these are in your notes. And so fill those notes in. All right, so here we have another example here. We have the people in the control tower, CT people, that's the control tower people. And then we have our friendly pilot in his little airplane. So the pilot has to look down to see the control tower. That's the angle of depression. The control tower people have to look up to see the plane. And guess what? The angle of depression and the angle of elevation are exactly the same. These angles are congruent. So the angle they're looking up is the same as the angle he's looking down, but notice it's from a different triangle, right? So this angle over here, right, that does not equal the angle they're looking up, right? But the angle over here, where the 2 is, does. Let's talk about why those two angles might be the same. All right, so here we have the picture a little bit larger. Right? So the angle of, and I have this in your notes, the angle of elevation is blank to the angle of depression. We're going to fill in congruent. And I hope you're thinking about why they might be congruent, and hope you notice that those are parallel lines. All right, so angle 1 is congruent to angle 2 because they are alternate interior angles formed by parallel lines. Angle 2 and angle 3, notice those two angles next to one another, they are complementary, a vocabulary word you need to know. So we've had 3 vocabulary words, complementary, and then angle of elevation and angle of depression. Right? Complementary means they add to 90 degrees. Okay? Right? So if I know this angle of, if I'm solving in this triangle here, and I know this, I should put a question mark there, that's known. I know that angle right there, that angle of depression, right? But I don't want to work with that one because that's not in my triangle. I want to work with angle 3. Well, angle 2 plus angle 3 equal 90 degrees. Right? So if I subtract angle 2 from 90 degrees, I'll have angle 3. Right? So together, those two angles form a right angle. So you can work with different angles. Right? If you remember that the two adjacent ones there, right, the angle of depression and the angle next to it that would form another right triangle are complementary to one another. Okay? Sometimes that comes in handy. Okay? Or you could remember that this other angle over here is the exact same measure and work with that angle instead. Right? But you have to make sure your angle's in the triangle. So if that's my triangle right here, the one I've drawn in black here, where I just put that right angle mark, I have to work with either angle 1 or angle 3 because angle 2 is not in my right triangle. Okay? So either I use angle 1 and remember they're congruent, or I use angle 3 and I remember they're complementary. So let's solve a problem. And here I have a drawing for you. So it makes it really not much different than solving for any old triangle. A parasailer is attached to a boat with a rope 300 feet long. The angle of elevation from the boat to the parasailer is 48 degrees. So elevation means I'm looking up, so it's at the bottom. Estimate the parasailer's height above the boat. So we're looking for the vertical height that the parasailer is above the boat. All right, so now we have our angle, and we have it all drawn out. We want to label our sides. So, of course, across the triangle, we have the opposite side. And, of course, across the right angle, we have the hypotenuse. And the trig ratio that uses opposite and hypotenuse, of course, is sine. So sine, and I think this is in your notes, sine 48 equals h divided by 300. We want to isolate our variable, so we'll multiply both sides by 300. So we have 300 sine 48 equals h divided by 300 times 300. There we go. Those cancel out. So we have 300 sine 48 equals h. And now we can just plug that right into the calculator. So 300 sine 48 is 222 point, we'll just put 2 decimal places, 94 feet. 222.94 feet. And of course we know that's an estimate because we rounded. Right? So that's how high he is up in the ground, above the ground, pretty high. Let's do another problem. Okay. So far, not a lot different than solving, with triangles until we get to this one. There's no triangle. We have to figure this out. Right? Well, we know it's going to be a right triangle. So a boy flying a kite. Here's our boy. Lets out 300 feet of string, which makes a 38-degree angle with the ground. So he's on the ground, and let's just say he's holding it with his foot, just for drawing purposes. Otherwise, I have to move my whole triangle up in the air. Beautiful right triangle there, right? Things are perpendicular with the ground. All right, so this is his kite string. Let's draw a kite. There we go. Oh, isn't that lovely? All right, so there's his kite string flying in the air, and of course the kite's going to go diagonal. The string's going to go diagonal. So that's going to be 300 feet right there. The string makes a 38-degree angle with the ground, assuming the string is straight. So straight does not mean vertical. It just means it doesn't look like that. All right, it's straight in the air. And usually kites are, right? They're being pulled by the wind. All right, we want to find out how high above the ground our kite is. Well, this is a lot like the other problem. Matter of fact, it's almost identical, except the angle changed. All right, so across the angle, we have the opposite side. Right? And across from the right angle, we have the hypotenuse. So opposite and hypotenuse would be sine. So sine 38 equals h divided by 300. So you notice the key differences between just solving for a triangle and solving a word problem is, notice I had to interpret the question and draw the triangle to match. Right? I had to pay attention, where's the angle located? Right? It's on the ground, right? So it's got to be on the bottom there, not up in the air, right? How's the string going? Okay, well, it's going to go at a diagonal, right? And we're finding the vertical distance that the height is from the ground, right? So, and then we labeled a triangle, right? So all of these steps we want to do when we're solving trig word problems. And if you do that, you'll set these up correctly. And if you don't do these, you're probably going to make a mistake. So we're going to multiply both sides by 300. So we have 300 sine 38 equals h divided by 300 times 300. Kind of wishing I didn't draw this right in the middle of the board because I have like no room to solve. Those cancel. So we have 300 sine 38 equals h. And now we will use a calculator. And so almost the same problem times sine 38, just 38 instead of 48. So now it's 100, what number is that? 184.7 because I got 698. So that's going to run all the way up to 7. So 184.7 feet. And we are done with our boy and his kite. Right? Not too bad. Maybe I'll do one more example. Well, that says example 2, but we just did example 2. So that should be example 3. So example 3, a ladder leaning against a wall. Right? So here's our ladder. It's leaning, right? It's not straight up in the air. Makes an angle of 74 degrees with the ground. So this is our ladder. Hey, let's make it look like a ladder. We can have fun with the triangles. There we go. So the ground is, well, on the ground. Up 74. 74 degrees with the ground. How high on the wall is the ladder? So we're looking at how high the ladder reaches. Right? And so the foot of the ladder, so we don't know we don't know how long the ladder is, but we do know the ladder is 6.5 feet from the wall. So from the ladder to the wall here, this is the wall, is 6.5 feet. All right, so here we have to read all these important things. So 74 degrees with the ground. It's leaning against a wall, so that means that's the hypotenuse. All right, how high on the wall is the ladder? We're looking for the side. All right, so you have to interpret the problem. That's the only thing that's different between these and the other problems that we've been doing. All right, so now let's label our sides. Of course, across is the opposite. We don't have the hypotenuse, we have another side, and it's right next to our angle, so it's the adjacent. Opposite and adjacent is tangent. So tangent 74 equals h divided by 6.5. We're going to multiply both sides by 6.5. And that cancels. So 6.5 tangent 74 equals h. And now I'm just going to plug that into the calculator. 6.5 tangent 74, and so it would reach 22.67 feet. Right? If we wanted to know how long the ladder is, well, then we'd have to use cosine, and then we could find out how long the ladder is. Right? So in class, we'll do some more problems, like a lighthouse and a tree and the school, and other exciting problems. And we'll look, maybe we'll look for some angles as well. Right? So that'll all be happening in class on Friday. So hope you enjoyed this podcast. See you later. Bye.